Working with figures on the coordinate plane, we want to think to ourselves, how can coordinate algebra be used to verify or prove geometric properties? Now, these properties are going to fall in line with those quadrilaterals that we have been working with over the entirety of the unit: parallelograms, trapezoids, squares, rectangles, and so forth. And knowing what those properties are, we can use some of the information on the coordinate plane to verify that. So looking at some of the things that we need to look back on or reflect on, the distance formula. The distance formula allowed us to find points, the distance between 2 points on the coordinate plane. Not a very straight line there, but however, you get the idea. How far are we going from this point to this point? And in doing so, we would use the coordinates of those in the distance formula. So we have here, it looks like we have, what, -2, 3, if this was a, let's see here, 1, -1, 1, -2 there, so we can sort of identify that. So we have -2, 3, and so in the other point is going to be a 4, -1. So as we put that into our formula, we've gone ahead and assigned this coordinate as x2, y2, and this coordinate as x1, y1. And then we substituted into our formula, and that's how we came up with the square root of 4 minus a -2 squared plus -1 minus 3 squared. Forgot one of my parentheses there. And as we continue to simplify, we get the distance is going to be equal to, this simplifies to 36 plus 16, or distance equals the square root of 52, which we could simplify that. We know that that is the square root of 4 times the square root of 13, and then so my distance is going to be equal to 2 square root of 13. And again, this is simplifying a radical, which we've been practicing, and of course you learn that in algebra, and we've been practicing it more in geometry. But let's see here, what could I have identified? The distance there, in using this distance formula, is derived from the Pythagorean theorem. So if we were to have drawn this imaginary triangle, this would have been a right triangle, and here you go. We would have had a measurement over here of 4, a measurement over here of 6. So that's where we end up here with 6 squared plus 4 squared. So again, it all works with the Pythagorean theorem. Let's see here, the slope formula. We want to the slope formula, we could turn around and say that it looks like we go down 1 or down 4 over 2, which is negative, right? We could just say, hey, the slope, it looks to be, we went down -4 and we went right +6, which is going to simplify to -2 over 3. That's looking at it, being able to come up with that information. But now if you have to do it algebraically or mathematically, we could do the same thing with our points. We could use our formula here and fill in our points, and we would have -1 minus 3 over 4 minus a -2, and that is going to give me -4 over 6, or again, -2 over 3, which was what we calculated over here. So that, just remembering, when we're working with the coordinate plane, these are two skills that we will come back and reflect on and use. And moving on, let's talk about the classification of these different shapes to where we can identify them on the coordinate plane. So we have the classification of triangles here. They include, right here, scalene, isosceles, equilateral, and right. Okay, so here we have a triangle with a right angle, so we know that that is going to be our right triangle. That's our right triangle. This triangle, our legs are the same, so this is our isosceles triangle. Over here, this triangle right here, it looks like all my legs or all my sides are equal. So we end up with a equilateral triangle. And of course, with the equilateral triangle, we know that all of my angles also equal. It's one of those characteristics or properties. And then last but not least, we have the scalene triangle. And that is a triangle where all the sides are different. Does not have any congruent sides. So those are our triangles that we want to be able to look for on the coordinate plane. So looking here, we have classifying a triangle in the coordinate plane. How do we use coordinates to classify triangles? Well, what we can do here is we can go ahead and fill in our points, because let's look at this, right? We have y, we have x. Filling our points, this looks like this is 3, 1, right? Point A. We have point B, which looks to be 6, -3. And then we have point C, which looks to be 0, -3. So those are the points that I can use when I start talking about this triangle. So if I want to find out the length, I can use the coordinate plane. So if I was trying to find out the segment of AC, the segment of AB, the segment of BC, we can use the distance formula to find those values out. So I'm going to set those up using those points. So by setting up first, let's find out how long segment AC is. So segment AC, I use my 2 points, 3, 1, and 0, -3. And I was able to come up with AC is the square root, and again, 3 minus 0 squared plus -1 minus 3 squared using the distance formula is equal to, when we simplify that to the square root of 25, and the square root of 25 we know is 5. So the length of AC is 5 units. Now if we continue on, let's go with AB. AB is going to be equal to, okay, so as we plug in our coordinates for point A and point B to find out how long segment AB is, when we go ahead and simplify that, we end up with the square root of 25 again, or 5. So if I know that AC is 5, AB is 5, it's leaning towards an isosceles triangle or possibly a equilateral triangle. And if I simply look here, the segment BC, I didn't have to do very much math for this one. I can count BC. So 1, 2, 3, 4, 5, 6. The length of BC is going to be 6. So in this case, I do end up with an isosceles triangle because my two legs are congruent. They're the same length. So there is the definition of that isosceles triangle. And let's see here. So is triangle ABC also a right triangle? And then we know that two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. So if we want to try and figure out, is it a right triangle, let's look at the slopes of these lines. And I will say that the slope of let's see, we'll just say the slope of AC, and then we want to do the slope of AB. And what do they equal? We can use the slope formula, but since I have it drawn on the graph, I'm just going to go ahead and count it. And starting from, we're going to do slope AB first. And AB, if I look, I can go from here in order to go from this point to this point, I go down 1, 2, 3, 4. So I have down 4, minus 4, and then I'm going to go right 1, 2, 3, which is a positive 3. So my slope is negative 4 over 3. Looking at AC, on the other hand, let's see here, we have a negative 1, 2, 3, 4. So I go down 4, and I go left 1, 2, 3, negative 3. So I have a slope of 4/3 for that. So I would say that these two lines, these are not negative reciprocals. They are just negative opposite signs of each other. So let's see here, two non-vertical lines are perpendicular if and only if the slopes of the are opposite reciprocals, and in this case they are not. This is not a right triangle. If it was a right triangle, one of the slopes would have been, in this case, if AB, if the slope of AB was negative 4/3, a right triangle, a perpendicular slope would be, the slope AC would be equal to a positive 3/4. This created a perpendicular slope, which is what we do not have. We do not have that. So that's why I say we do not have a right triangle. Okay, so moving on, and let's talk about some of the quadrilaterals that we could find on a coordinate plane. And again, knowing some of these characteristics that we have been dealing with. Let's see here, classification. We can see here the quadrilateral classifications include parallelograms, rectangle, square, rhombus, trapezoid, and kite. So let's see, change it up a little bit. We have here a parallelogram because we have two sets of opposite sides are parallel. We also know that in that parallelogram that these sides are going to be congruent. And a rectangle, we have the same properties as a parallelogram, rectangle. We do have two sets of opposite parallel sides again, and of course we do have the same congruency of opposite sides. The added portion of a rectangle is that we have 90-degree angles. So that is creating a rectangle. We have, let's see here, this thing right here, what does that look like? Two sets of parallel lines, two sets of parallel sides. We have all things congruent, all sides are congruent, so that looks like a rhombus. Looks here we have one set of opposite sides that are parallel, so we have a trapezoid. Here we're looking at a kite. So a kite is a quadrilateral with two adjacent sides that are congruent, right? These two sides are congruent, and opposite sides are not congruent. And I'm pretty sure we're going to find out that our diagonals intersect at a 90-degree. I don't know if that's going to be an issue or not. And then, of course, we have the ever-popular square, which is both a rhombus and a rectangle because it has 90-degree angles, 4 congruent sides, and of course it still has the parallelogram rules of two opposite sides are parallel. So those are some of the quadrilaterals that we have been working with and looking at those characteristics on the coordinate plane. So let's see here. Looking at this quadrilateral, which is here, it says classify a quadrilateral on the coordinate plane, and we're going to classify A, B, C, D here. And we can first go ahead and fill in the points that we see here. Let's see here, point A is going to be 1, 2, 3, 4, 5, so that is going to be negative 5, 1, 2. B is going to be negative 1, 1, 2, 3, 4, 5, 6, positive 6. C is going to be 1, 2, 3, positive 3, and a positive 2. And D is going to be a negative 1, and let's see here, a negative 2. So those are the points we were able to use now that we're on the coordinate plane. So as we look here, what are the slope values? So as we calculate the slope here for AB, BC, CD, and AD, we're going to use the points connecting those segments. So as we've gone and plugged in the values and determined the slope of each segment, we can see that segment AB is going to have a slope of 1. Segment BC is going to have a slope of negative 1. Segment CD is going to have a slope of 1. And then segment AD is going to have a slope of negative 1. And what we can see here is those are actually opposite reciprocals. So it turns out that since these are opposite reciprocals, we end up having right angles at our vertex, which is going to indicate a rectangle. Now, if we can determine that our sides are all the same length, we could have a square is a possibility. So as we go in and we use the same information to find out the lengths of each one of these sides, and I've gone ahead and I've filled the information in here to find out how long are each one of these sides using our distance formula. It turns out that AB is going to be the square root of 32 units. BC is also going to be the square root of 32. CD is the square root of 32, and we multiply everything out. And then AD is also the square root of 32. So it turns out that it looks like all of our sides are going to be congruent. So we do have what we have determined here is going to be a square. So if all the sides, there you go, we have a square. Now, if we continue on and we talk about the perimeter of that square, we would go ahead and calculate the perimeter. Calculate the perimeter by adding up the sides, the exterior boundary of the item. So I have here that the perimeter is going to be the length of AB plus BC plus CD plus AD. And so we know that P, perimeter, is going to be equal to, substituting in those values, the square root of 32 plus the square root of 32. So we've substituted all their values in, so it turns out that P is going to be equal to 4 square root of 32. Now we can simplify that further. We know that we would have 4 times the square root of 16 times the square root of 2. So, and then so that would be 4 times the square root of 16 times the square root of 2, which would simplify down to 4 times the square root of 2, or 16 square root of 2. That is actually what the perimeter in simplified form would equal. So there you have it. Perimeter equals 4 square root of 32. Yes, the better answer is simplified to 16 square root of 2. So continuing on, as we talk about finding diagonals on the coordinate plane, we're going to use, one of the things we're going to talk about is using the midpoint formula, because the diagonals, where do they intersect? In many cases they intersect at a midpoint, and the intersection point becomes the midpoint of the two diagonals, therefore showing that they bisect. But let's see here. So to prove the diagonals of a square Qrst bisect each other, first you must find the midpoint of SQ and TR. So the midpoint of SQ and TR, we want to find that point right there, and we want to determine what that value is. So if we substitute in, let's see here, we have points that we need to substitute in to find the midpoint. So Q is going to be negative 3, 5. R is going to be negative 1, 3. S is going to be negative 3, 1. And T is going to be negative 5, positive 3. So those are the points that we're going to use in our midpoint formula. So the midpoint of Qs is going to be x1 plus x2. So we have negative 3 plus a negative 3 divided by 2. So there's my x value, and then I have my y value is going to be 5 plus 1 divided by 2. So it looks like my midpoint is going to be, let me make that a little bit more friendly. So negative 3 plus a negative 3 divided by 2, and then a 5 plus 1 divided by 2, which turns out that we are going to have, what, negative 6 over 2 and 6 over 2, which simplifies to negative 3, 3. And, okay, so that's 1 point. So the midpoint of Qs is negative 3, 3. So then as we go to calculate the midpoint of RT, we would end up with negative 3 plus a negative 3 over 2 and a 5 plus 1 over 2. So it looks like the midpoint there is also going to be negative 3, 3. So my midpoints for both my diagonals are the same, so they do bisect each other. The midpoints bisect each other. So that's since they have the same midpoint. And there you go. That's being able to identify some characteristics. So that point right there is going to be the midpoint. And continuing to classify using the theorems, we need to remember that the converse of the diagonal theorem is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if they bisect each other, so we would have this parallelogram. If the two diagonals bisect each other, then we know that this segment is equal to this segment is equal to this segment. Okay, let's see here. So we have the converse of the side theorem, and it says that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, we would have, this is congruent, so if opposite sides, both pairs of opposite sides are congruent, that is the converse of the side theorem. And then we have the single opposite side pair theorem. So if here, let's see, if you have opposite sides that are congruent parallel, then the quadrilateral is going to be a parallelogram. So they are opposite sides that are congruent and parallel. And let's see, what else do we have? We have the rectangle. Okay, so when we have a rectangle, let's see, rectangle, the diagonal theorem, a parallelogram is a rectangle if and only if its diagonals are congruent. So on a rectangle, we have our diagonals are going to be congruent. So if we have A, B, C, D, then I know that segment AB is going to be congruent to segment CD, and again, the diagonals are congruent. For the angle theorem, well, if we have one, we only need one right angle. Okay, right angle to prove that a parallelogram is a rectangle, because again, if we have one right angle, we talk about same side interior angles, we talk about opposite angles are congruent, same side interior angles will total to be 180 degrees. So once we have 190-degree angle, there's a lot of information that we'll go ahead and fill in, providing the remainder of those angles. for a rhombus. Now, for the diagonal theorem for a rhombus is a parallelogram, or a parallelogram is a rhombus if and only if the diagonals are perpendicular. Okay, so again, one of these rules that we've come up with, or we understand, is that if my diagonals intersect at a 90-degree angle, then they are perpendicular. And again, the rhombus, we have all four sides are going to be congruent. And let's see, moving forward, we want to be able to prove the classification of quadrilaterals on the coordinate plane. So first you want to prove we're going to prove the quadrilateral is. What is this quadrilateral? It looks like a rectangle. And we can prove that by doing some of the same information that we've done to date. Let's go ahead and label our points. So let's see here, M is 1, 4, N is 3, 1, right? I'm looking at the ordered pairs of these points. P is going to be -3, -3, and then L is going to be -5 and 0. Okay, so when I use those points to find out what my distance are, my lengths of my sides, right, I find out that LM is going to be the square root of 52. I find out that PN is going to simplify to the square root of 52. So let's see here, the square root of 52, the square root of 52. So far, I have congruent opposite sides. Let's see here. LP is going to simplify with the distance formula to the square root of 13. And then finally, MN is going to simplify also to the square root of 13. So I do have two pairs of opposite congruent sides. Now we want to prove that the parallelogram is a rectangle. So continuing on, what could we do? We could figure out the slope, right? If this angle is 90 degrees, then we would have the 90-degree requirement for a rectangle, because if one of the angles is 90 degrees, all of them are going to be 90 degrees. So let's see, LP, let's find the slope of LP and NP. So we are going to find the degree measure of, right here, what is that degree going to be? So we are looking for opposite reciprocals, which would indicate perpendicular intersection. So LP is going to be, let's see here, 0 minus -3, of course remembering your slope formula, and -5 minus -3, which becomes -3. +3 over -2, and which could also be -3 over a +2, which is the same thing as -3 over 2. Often those darn negative signs tend to throw students for a loop. And let's see here, NP is going to be 1 minus a -3 over 3 minus a -3, which is going to become 4 over 6, which is going to be 2/3. So these two turn out to be opposite reciprocals. Opposite reciprocals. So therefore, we do have the definition of 90 degrees, right? They intersected perpendicular. So yes, this turns out to be a 90-degree angle. So we do have a rectangle. So looking at two examples here, or three examples, let's see here. It's asking HIJK is a parallelogram because the midpoint is blank, which means that the diagonals bisect each other. So I'm hoping that if the midpoint is something, right? The midpoint is the same location. So if we were to calculate the midpoint between HJ and then the midpoint between KI, then those would turn out to be congruent, or I'm sorry, not congruent. If they intersect at the same point, then we know the diagonals bisect each other. So we were actually trying to calculate the midpoint of those two segments. And we will do that by using the midpoint formula and by using the points of those. So as we calculate the midpoint of HJ, we are using the x1 plus x2 divided by 2, y1 plus y2 divided by 2. And it turns out that we are going to have 2 over 2 and 0 over 2, or should I say x is going to be 1, y is going to be 0. So it looks like that's pretty close for our midpoint for HJ, and then doing the same thing for KI. So again, the midpoint KI is going to be equal to, let's see here, I'll use negative 2 plus 4 over 2, and then I'll use negative 3 plus 3 over 2, which is going to simplify to, just like before, 2 over 2 and 0 over 2, which is 1, 0. So my midpoints of those two are the same coordinate, so they do intersect each other. So the midpoint is 1, 0, which means that the diagonals bisect each other. And we find that this segment is equal to this segment is equal to that segment. So there you go. We were able to find out that they do, in fact, bisect each other. Looking here at example number 2, it states LMNP is a parallelogram. Prove that it is a rectangle. Okay, so to prove that it is a rectangle, I need to prove we have opposite sides, parallelogram, right? So I need to prove that I have two congruent parallel opposite sides, and I have a 90-degree angle here. So the slope of these are going to be opposite reciprocals, which could be a lot of work. So let's see, I'm going to use the distance formula for LM and PN. So we will tackle this, in stages. So the distance formula for that, remember your distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared will give me the distance. And we're going to use that for all four sides. So as we work through, we're using our ordered pairs to find our points, and x2 minus x1 squared plus y2 minus y1 squared, which turns out to be the square root of negative 6 squared plus negative 3 squared, which is the square root of 36 plus 9, which is the square root of 45. And we are just simplifying it along the way so you can see all the steps. Okay, so as we do, we find that we have the square root of 45 for these two sides. So those two sides are opposite and congruent. And let's do the other two sides. Okay, so as we do the distance formula for those sides, it turns out that we do have two sets of opposite congruent sides. And now that is one criteria for a rectangle. Now to find out that they're parallel, we could do the slope formula, or since I can see this, I can see that the slope, let's see here, the slope of ML, the slope of PN, the slope of, we have LP, and then we have the slope of mn. Remember, it's the rise over run. So as I look at these, the slope of ml right here, I go from here and I go up 1, 2, 3. I rise 3 and I run 1, 2, 3, 4, 5, 6. So the slope is 3/6, which is equal to 1/2. And if I look, the slope of Pn is going to be up, or 1, 2, 3, 4, 5, 6, up 3, 1, 2, 3. So I have the same slope. The slope of LP is going to be down 1, 2, right 1. So we have a -2/1. And the slope of mn is going to be down 1, 2, right 1. So again, -2/1. So we have these two sides are parallel. These two sides are parallel, so they are both opposite and parallel. So we do have congruent parallel opposite sides. And then if we look, we need to know that this is 90 degrees. So if those two slopes are opposite reciprocals, then they would be 90 degrees. And if you look, 1/2 and -2/1, these are opposite reciprocals. So therefore, that is a perpendicular slope. The slope of 1/2 is perpendicular to the slope of -2/1. So those are my opposite reciprocals. So there you go. We're able to prove that that is a rectangle because we were able to identify some of the sides, the parallel, the angle measurements. Okay, so example number 3, you could probably stop at this point in time and say, hey, you've got a good grasp on what you're doing, you can move on. But if you need a little bit more help, we're going to go and look at example number 3. And this starts from, it hasn't been graphed for you, so you have to graph it. So you're going to have to graph your points. You may not need to graph the points to look at it. We know that we have an object that is four-sided. We have ST, UV. Those are my sides, or my vertexes. They've given me the coordinates of those vertexes. I know that S is on the big coordinate plane. S is -14, which is going to be up here. T is 110, which is going to be about there. U would be -3, 0. And then V would be -13 and 4. So, some shape like this in general. So if I were to put that on the coordinate plane, -1, let's see, we're going all the way over to -9. So what I'm going to do is I'm going to count by 2s. That's just going to make things easier. So this would be 2, this would be -2, and this will be 2, 4, and so forth. So we have S is going to be -9, which would be 2, 4, 6, 8, 9 right here, and 14, which would be 2, 4, 6, 8, 10, 12, 14. So there is my S. We have -9, 14. Let's see, what else do we have? We have T, which is going to be 1, and 10, which is 6, 8, 10 right here. That is T, which is going to be 110. We have U, which is going to be -3, -3 and 0, which happens to be, bam, right there. And I will say U is -3, 0. And then finally V, which is going to be -13. So this was 9, 10, 12, 13, -13 and 4. So that is V, -13 and 4. And look in here, we have this shape. All right. my lengths. Without doing any calculation, I could say that I'm going to overlap some triangles here. We could do it mathematically using the distance formula, but I'm going to try to overlap some triangles and say VS. If we were to create this triangle, that VS would be the hypotenuse. So this length is going to be the length of 4. This length is going to be 2, 4, 6, 8, 10. This side would be 10, which means that the hypotenuse is going to be the square root of 10 squared plus 4 squared, or the square root of 116. If we come over here to the other side, its opposite side, and do the same, right? We have 4. 4 is the side length, and then we have 2, 4, 6, 8, 10. The side lengths are both 10, so this would be the square root of 116, just by looking at the properties of that right triangle. Okay, and if we turn around and we do the opposite sides, let's do ST. So here I go up and I go over. I went up 4 here for this triangle, and then I went over to, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now let me count that again. From 1 to -9, so 2, 4, 6, 8, 10. So this side is 10, this side is 4. So it looks like this measurement right here is going to be the square root of 116. And if we look down here, it turns out that these measurements are all the same. So this is the square root of 116. Now I just did that mathematically, but if we check it, the distance is equal to the square root. We just pick one of these, and I'm going to go from the ST, okay? So we have the square root of -9 minus 1 squared plus the y2 minus y1, so that would be 14 minus 10 squared is going to be equal to the square root of -10 squared plus 4 squared, which is going to be equal to the square root of 116. So there you go. We did it using the dist formula. So the distance formula proved of those quick calculations that we made by drawing triangles. So we know that all the sides are the same length. So we have opposite congruent sides. We also have sides that are all congruent, so it could be a square or a rhombus. And then we just need to figure out the slope of this line and this line. So as I go up 1, 2, 3, 4, 5, I went up 10 over 2. So the slope here, my slope is equal to a positive 10 over 4, which is 5 over 2. Then the slope here on this side is going to be, my rise was minus 4 over 10, right? Because I went down 4 over 10, which is -2 over 5. And if we compare the two, 5 halves and -2 fifths, those are opposite reciprocals. So the slope of 5 halves is going to be perpendicular to the slope of -2 fifths. So sure enough, we do have 90-degree angles right here. So if that one's 90, we know that that one's 90, that one's 90, that one's 90. We know that this side is congruent to this side, which is congruent to this side, which is congruent to this side. We know that this is parallel to this. We know that this is parallel to that. So therefore, we end up with a square with all those properties put together. And as we focus on the coordinate plane, you have a little bit more work because it's a little bit more algebra and having to graph things and identify those with those and using those three formulas, your midpoint formula, your slope formula, your distance formula, it's going to help you pick those characteristics out to identify.